Hello everybody, welcome back to the channel. This is an addendum video to yesterday's C-beam fixture plate upgrade video. Yesterday I was talking about how I was having some issues with feeds and speeds and the fact I didn't check my post processor, so I broke the only 1/8 inch end mill I had in stock at the time. I received some more in today and I successfully milled the 2 brackets I needed to mill for this project portion. So take you along and show you what ended up being done. I also was able to get the menus fixed so you can actually see what I'm talking about when I'm talking about feeds and speeds and all the other settings. And we will go through those in a few minutes here. Alright, we'll start this off with the 2D adaptive that I did for the 5 holes, for the clearance holes for the 5mm screws to fit through. I had started out yesterday with a 16,000 RPM spindle speed. I also started that today, but I ran into some issues I'll talk about in a second here. I also was at 1,000 cutting feet millimeter, or rather 1,000 millimeters per minute of cutting feed rate that I had to reduce to 500. That'll also be described in a few moments here. And as I alluded to earlier, I switched from a 3 flute end mill to a single flute end mill, and I seem to get some pretty good results. I did break one end mill, but that was due to a couple issues that I resolved by changing some of these settings here. Also, I guess my machine's a little more accurate than it used to be. I haven't really messed with it much, so I would take this 0.5 millimeter out and just have it be zeroed. I was getting a little bit of trailing into the fixture plate below while doing that. I guess my machine's a little more accurate than it used to be, which is a good thing. It's just I was used to the other settings, so I had to change it. And then I did pretty much the same thing for the 2D contour pass I did too. I had to bring it down to 8,000 RPM and 500 millimeters per minute, and that seemed to fix the problem. The issue I was having with the single flute end mill was that I was getting chip welding, where not where that is the chips will get so warm within the part you're cutting that they'll actually adhere to the cutting tip. So what happens is, I'm sure you've seen this happen in drill bits and stuff, where you get galling and you get a little bit and your end mill gets dirty, and then it progressively gets worse to the point where you're no longer really cutting. It's kind of a friction cut at that point, and at that point it's just a matter of time before the end mill, well, shatters. And I'll show you what that looks like here in a moment. As you can see on this successful machine job, I lowered the spindle speed, I lowered the feed time, and I get a successful cut. Let's speed this up a little bit and I'll show you the end results here in a minute. I'm also working on figuring out the optimal camera angles. So I think that the angle I'm using right now is probably not too suitable, and I'm going to have to develop a different mount to stick the GoPro in a better place. On that scene where you saw me cutting the part from the horizontal position, I like that idea, but I'm going to have to build a swing arm because I had to hand hold that the whole time I was there. And I don't really feel like hand holding a GoPro for 20 minutes during operation. As you can see, the parts turned out great. I'm pretty happy with them, and I hope to get back to the other portions of this fixture plate build soon. I think for the next episode, I'm going to make a video on drilling with a router type system. It's a little different than it is with a traditional CNC machine or manual mill for that matter. And the simple reason is that routers tend to have high spindle speeds. The 2.2 kilowatt spindle I have is not going to spin below about 8,000 RPMs, and that's about, I'd say, 7,200 RPMs more than you really should be drilling with. So you have to take some care with your strategy on drilling. So we're going to work on that next video, and it should be interesting. We'll see where everything fails and where everything works well, and hope for the best. Thank you for watching, and see you next time.